I'll have to sit here. Okay. So these are just some of the things that are showable. This distribution that we got here is a modified distribution of our SDK version. Our SDK includes SimNow and includes a way of hooking some things into COTSon. So I'm going to show that later. But we can do other stuff, like, and we're going to do like those 8 experiments. Some of them are more complicated. And we're going to show you exactly what each of those means. And please, now you can really stop me at any time and tell me, what's that? Because that's important. Okay, so the first thing that we're going to do is the functional simulation part. The functional simulation is really just letting SimNow run alone. But we're going to use our own tools so that you get to understand what it does. So the first thing, if I'm here, I don't know what happened.
You have to deactivate the mousepad.
Yeah, I don't know where it is.
What are you looking for?
Deactivate this mousepad.
Do you have Synaptics installed on the Linux machine? Yeah, it's a problem. The problem is the error.
Doesn't matter, I won't touch it. I try not to touch it. Okay, so this is basically the structure of the SDK. SDK is basically something that you dump into your disk and you get a particular structure. Inside the SDK directory, by the way, I didn't say this. Even though SimNow runs in Windows or Linux, COTSon only runs in Linux. It may run the guest operating system inside maybe Windows or maybe Linux or maybe whatever SimNow supports many other operating systems, but external. And so we only build it for Linux. I guess that it wouldn't take a lot of work to support it to Windows, but we're not interested in Linux. Maybe that's a stop for you. So here you get a couple of executables and you get a make, and if you do a make, nothing needs to be done. I'll do it again, make. Basically what you're doing is you're building the abeterno.so. The abeterno.so is the dynamic link library that we pass to SimNow, and that's basically COTSon. That builds up COTSon. It's where everything is located. The rest of the things in this directory are examples of what needs to be done, and the abeterno.so also includes a static link library that we need to use. So that's the rest of our simulation. So here is how we build the abeterno.so. I'm also going to build this application, which we'll use later. And this is a shell that's another century. Okay, so the first thing is that since we needed to program and give lots of options inside SimNow, what we do is we have a Lua functional, I don't know if you know Lua. Lua is a scripting library, very similar to JavaScript or other scripting languages. And we basically, each of the scripts that we have and each of the tools that we have accept a series of commands. Each command may be a Lua command or the name of a file. If it's the name of a file, you assume that, so if you pass the name of a file, a Lua command, and the name of a file, basically you're saying that the concatenation with the Lua commands in the middle of all that application is what you give to COTSon. And COTSon will instantiate that application and will run it for you. So basically it's a way to script and not only to give options to the different parts of COTSon, but also it will allow you to put any kind of program inside. And some of them you may program a function that gets called later. For example, we have one of those to build a whole memory hierarchy because it's very complicated to build a memory hierarchy if you only got static options and all that. So let me. Do you have any video? Sorry. Okay. Do you know how to switch off these?
No, you can't switch it off.
You can't?
Well, not now.
Do it for Ubuntu. Okay. I'm not an Ubuntu fan, they are Ubuntu fans. You got all these problems. You should have been Debian. Okay, so this is a very simple Lua application, which is basically, we have the sim now space. This is, since it's functional only, you will only have sim now. We basically say that you want to run a functional simulation so that mainly at the term is not loaded. We want to run it interactively, meaning that we want the sim now GUI to appear. Normally we don't want it to appear in most applications because we basically want it to run batch. And we want to use a particular BSD, a particular HDD, and we want to have journaling on that disk. So if you execute this by saying then COTSon node input functional, it will open up the GUI. The shell that appears on the other side, which Teresa talked to you about, you could do stuff on that shell, we own it. So if you use COTSon, that shell, you can use it, but you have to really know, because we are using that shell through various different mechanisms to interact with him now to make it what we want. This is just a bogus order because it's interactive. Okay, and here you can do anything. So some things that are planned. One of the things that we have here is already running. Is we have a couple of applications, so you can run any kind of application inside and you can test it. Like, let's say run spec 176, and this will run GCC, which is one of the specs, and this is the simulation that we're doing, basically. So this is how you run an application inside COTSon. I'll talk more about that later. And then other stuff that we constantly use is we also use xget and xput. Go to the next slide. But I wanted to talk a little bit about how to run an application inside of VM, which in this case is sim now, but it may be in other case. Most people, when they use simple scaler, they basically tell simple scaler to run one application with a series of parameters, and that's mainly what microarchitectures do. They don't really want a system. In order to do that, we have to decide. So there are various ways of doing it. We normally, what we do is we send keystrokes to sim now, and we'll show you examples of how to do that. But when you're sending keystrokes, you have to take into account that if you send too many keystrokes, those keystrokes are going to be handled by a operating system that's going to lose some of them. So the other way is sending mouse movements, which we haven't really implemented because we're not into the GUI development stuff. But in order to start something inside sim now, you have to really understand that you have a virtual machine, a complete virtual environment, and that you have to give it something. So mainly what we do is we leave a terminal open and focused, and we send keystrokes. And the other basic thing that we do also is we also pre-start applications. So if an application is very complicated to start, you run everything with a GUI, and whenever you think that application is started, you stop, you save that BSD, and use that BSD as a starting point. So if you run with that BSD, that application would already have started, and you can simulate the timing from that on. Okay? So, yeah, and if we, okay, I killed this, but this should run at approximately 182 bits. You'll see a decrease in this in this speed for the next things. So let's go to the next. Okay. Can we go to the next slide, please? Okay, so we're gonna learn how to develop with our SDK fake timer, which basically gets all the instructions and dumps them to disk. Okay, and then we'll learn a little bit more about our Lua language and how to interact with COTSon, because this is really a COTSon application. So the first thing to do is to, I'll open, let's assume that you get access to this model. This is a model that you could build. It's a CPU timer model, and it's very simple. We don't do anything here, but mainly what you have to define is you have to define 3 functions, and that has to do with something that we'll explain a little bit later about the simple warming and full warming or the simulation of an instruction. We only are going to implement in this one the simulation part. And basically,